Well, hey everyone, welcome to Quick Soil Mechanics Lessons with Brian. Continuing with liquefaction, simply explained in 12 acts. Act 8, hysteresis and stress reversal. So here we've got our stress-strain axis. We've got our illustration of a triaxial sample in compression off the left-hand side, showing the orientation of principal stresses. Remember, sigma 2 equals sigma 3 in a triaxial test. Let's make a little bit of room at the bottom. We will have compression at the top. That's the normal thing that we've been talking about through all these lessons. And then we can also have extension. Now, extension is kind of a funny name for it because we're not actually stretching the sample, but you can have an extension test after consolidation if you decrease the axial stress at a constant radial stress or increase the radial stress at a constant axial stress. Let's make a little bit of room on the left-hand side because we can also have negative strain, right? Okay, now, what happens if we load and unload, compress and extend a sample? We have this nice elastic deformation. The sample goes up, comes back. We can call that a modulus, a stiffness. Comes back to the same point. So that is elastic strain. So what is hysteresis? Well, hysteresis is if we go up and come back not to the same point. So here we can see that there's been both elastic and plastic hysteresis. It doesn't come back to the same point that it started out. It'll get a little more exciting in some future videos. Let's go back to our normal stress, shear stress axes. Scoot that up a little bit so we can have our compression and extension, and get back to our more circles. So we've consolidated our material to a point, and then we've started increasing sigma 1. So sigma 1 is increasing, sigma 3 is staying at the same point. We have these more circles that get larger and larger with sigma 3 staying in the same place. Sigma 1 is increasing until it hits its friction angle. And if we wish, we could replace those circles with points at the top of the circles. This is the MIT method. Those all fall in a straight line. And we can replace all those dots with just the straight line. So this is the MIT total stress path for loading. Okay, we've gone through that a few times. And it's always good to get a reminder. There's also a similar stress path for unloading, also in compression. This is not too important to us right now, but there's also a similar stress path in extension for loading and for unloading. Well, that's a lot of information for one day. So we will quit there. There's a lot of stuff going on. Watch it again if you need to. It's going to be really important for the lessons that are coming up. And until next time, hang in there.